This is CS1101 Lecture 5.2. Today we're going to be going over the character wrapper class, overloading methods, and revisiting the scanner in a bit more detail. So as we've mentioned before, characters and strings are different in Java, and in most languages. A string in Java is denoted by the double quotes. So to define a string literal, you surround a string of characters with double quotes. However, if we have a single character surrounded by single quotes, then we have defined a char literal. So if h is in my string, so we have assigned the value h to the string my string, what is my string plus 1? It would be h1, because a string plus an integer in Java is a string. However, if the character literal h is in my char, what is my char plus 1? Well, it would be the ASCII representation of lowercase h plus 1. The ASCII representation of lowercase h is 104. So we have 104 plus 1. This is going to be equal to 105, obviously. And if we interpret that as an ASCII character, then this is lowercase I. So as you know by now, a string is an object, and objects contain data and methods. So we can store the data h in my string, but then we also have access to the methods such as toUpperCase or length. toUpperCase is going to return a new string object with all the characters in the original string in uppercase, so capital H. And then length is going to return the length of the string, in this case 1, because it's only one character long. Then char at, and then give it the index as a parameter, is going to return the char at a specific index. So in this case, it's going to return the character h, stored in the char variable first. So strings are objects. However, chars are a primitive type like integer. So there are no methods to call on it. You can't call toUpper on a char variable. For instance, if we were to code this, we declare a variable of type char called myChar, and we assign it the value h, and then we attempt to call some method toUpperCase on myChar. The compiler is going to throw an error and say something to the effect of char cannot be dereferenced. And so let's just take 1 second and understand what that means. When you use the dot notation, what you're telling Java is that the thing before the dot is a reference. So you're saying, here's a variable that contains a reference. Go to that reference and use the method toUpperCase. So when we type this into Java, Java says this is a char. It's not a reference to an object. I can't go there. That's not a place. And so it says we can't dereference this. So since chars are not objects, we don't have any built-in methods to handle doing some nice things like toUpper and those sort of operations. So instead, Java has built in a wrapper class called character. And this wrapper class provides a lot of those methods which we don't have built into the char type. This makes working with them significantly easier, similar to how using the math method makes arithmetic a lot easier, because we already have the methods pre-made and we don't have to develop the code ourselves. Now, the methods which are built into the character wrapper class are different than the string class methods, even though they may have the same name. So the character class methods all take a single character as a parameter rather than a string, or no parameters at all, as might be the case in the string class. So some of these common methods built into the character wrapper class would be the to uppercase. So the syntax would be character, which is the class. We don't have to create an object because this is a static method, so we don't have to make an object to be able to use the methods. I'm pointing this out because in order to use string methods, in general we have to make a string object. That's not the case here. We can simply, just like we did with math, say character dot to uppercase, and we're making use of the character class without instantiating an object. So character, which is the class name, dot to uppercase, but here's the difference. We have to provide a parameter, and that parameter is the char that we wish to convert to uppercase. So both of the calls that we see here would return uppercase A, a character uppercase A. To lowercase is the exact opposite. It's going to return lowercase a in both situations. Is uppercase is going to return a Boolean value. So we see the return type here is char. Return type for is uppercase is Boolean. Is lowercase is Boolean. So if we pass the character lowercase a to the method is lowercase, which is built into the character class, we will get the return value true. Is whitespace is helpful sometimes because it will return true for both spaces, but also tab characters and new line characters. So is whitespace of a space character is true. Is whitespace of the tab character would be true also of the new line character. Is letter tests to see if something is in the alphabet, right? Is digit tests to see if it's a numeral. The list we've presented so far is far from exhaustive. To see more of the available methods, reference the Java documentation at docs.oracle.com, or there's many tutorials available online that will take you through the available character wrapper methods built into the character wrapper class. A way that we would use this typically would be something along the lines of an if statement, and inside the if statement we need to have an expression that's going to evaluate to a Boolean value, and so we can use one of our character wrapper methods to test to see if a specific character is a letter. So this is going to return true if the value stored in the variable ch is a letter and false otherwise. So this will cause the statements following the if statement to occur if the value in ch is a letter. So to make the differences between string methods and character methods absolutely concrete and clear, we have defined a string called str, and we've assigned it some value, it doesn't matter, and we have a char variable called ch, which we've assigned some value. To call a character wrapper class method on ch, we say character dot to uppercase, so character is the class name, and then to uppercase is the method in the character class we wish to use, and then we have to provide the argument. So the argument in this case is going to be ch. It's the character which we wish to convert to uppercase. And then we are storing this into our variable ch. So this method will return a char value which we store in ch. In the following line, in the following statement, we have the string variable which we are going to dereference. So we have a memory location, and we say Java, go to that memory location and use the to uppercase built into that method. Well, we don't have to give it a parameter because that to uppercase already is aware of the data which is stored in this particular string. So this is a string object location, So when Java goes to that location, at that location exists both what we stored in the string and all the methods which are built into the string class. So we don't have to pass it what we want to convert to uppercase because it already has that information stored in the object. And finally at the bottom, notice how we would check to see if a character only contained white space versus checking to see if a string is empty. So in both cases, the character.isWhitespace method will return a boolean, and the string.isEmpty method will return a boolean. However, it's possible to declare a string that is completely empty, so we have the isEmpty method. It's not really possible to pass a char that's empty, so the equivalent would be testing to see if that char was white space. So let's consider how to use both the character wrapper class and string object methods to accomplish functionality. So in this first example, we want to check to see if the first character of a string is a digit. Well, there's a handy method built into the character wrapper class, which is the .isDigit method that will return a boolean of true if a character is a digit. But a string is not a char, so we can't pass the string directly to the character wrapper class. So rather, what we need to do is we need to use the built-in method to the string object, which will return the character at index 0. So index 0 will be the first character in a string, and this method returns a character value. This character value will then be the parameter which we pass to the isDigit method. The isDigit method will then return a value of true or false. So the way that this will execute is we have some string which is stored in the variable str. In the if statement, we will evaluate the Boolean expression. To evaluate the Boolean expression, we have to evaluate the parameters which are passed to the method, and to evaluate the parameter, we have to evaluate the method .char@. So we go to the string object which is stored at the location str, and we will get the char which is at index 0 of the string. So we get the first character in the string, and that is returned as a char value. That char value is passed as a parameter to isDigit. isDigit will then return a Boolean value to our if statement. If this Boolean value is true, we will execute the statements inside the curly braces following the if statement. And in this case, it would print out name cannot start with a number. So what we're doing here is checking to see if a string begins with a number, and if it does, we say that's not allowed. So we could also check to see if the final character in a string is uppercase. So we're going to do a very similar process. We're going to get the last character from the string as a character value, a char value. Then we're going to pass that char value to the character wrapper class isUppercase method. So to be able to get the char, which is at the end of a string, we need to take the string length and subtract 1. Remember, strings are indexed starting at 0. So if a string is 12 characters long, the last index is going to be index 11. So we get the length and subtract 1. This is the index of the character we wish to obtain. So the char@ method will return the last character in the string. That char is passed to the isUppercase method built into the character wrapper class. isUppercase will return a Boolean value of true or false. If the value is false, we will print out string ends with an uppercase letter. So always be careful to use the right syntax, because if you're dealing with a string object, you use the variable name, dot, and then whatever method you want to use. However, if you're using the character wrapper class, you always use the name of the class, which is character. So there's no way to create an object of type character, because character is not an object class. So to use it, we name the class character dot, and then the method name is digit. So now let's shift gears and talk about an idea known as overloading. And we talk about methods being overloaded. Now, it can be a slightly misleading term, because in my mind, the idea of overloading sort of invokes this negativity. Like, if you overload on classes or you overload your schedule, then you're doing more than what you can do. That's not what is being conveyed. The idea of overloading is that a single method name can be applied to two different methods, provided that the parameter list is not the same in both methods. So the reason that that's important is Java will actually use the types of the variables which are passed to the methods to figure out which of the two methods should be used. So in Java, you can have more than one method with the same name, provided that each method has a different either number of arguments or type of the arguments. So here in this statement, we discussed that the number of arguments and the types of the arguments are what the compiler uses to determine which of the available methods should be invoked. So one of the interesting things is that there might be a situation where there's no exact match. Perhaps you have attempted to pass an integer into a double parameter. Well, in this case, Java will try to promote those data types which it can, and it will again check to see if there are any methods which match. And if there are still no matches, then you will get an error saying that the compiler can't determine which method to use, which method is being called. Overloading is one of those very useful tools that programmers use to make code seem much more seamless and easy to work with. So for instance, it would be pretty annoying if the print line statement couldn't accept integers. Let's say that you had to have a different method to deal with printing an integer to the screen versus printing a double versus printing a string. But realize, print line is a method, which means it has a parameter or parameters, and we are able to print integers, doubles, strings, characters, any of these types we're able to print to the screen without any issue. However, if we know that we can't assign a double to an integer type, so if the parameter in the print line statement had been declared as an integer, we wouldn't be able to pass a double. Also, we wouldn't be able to pass a string. So it kind of raises the question, well then how is the information getting into the print line statement? The answer is there are actually multiple print line methods built into the system.out object. And it knows which of the available methods to invoke based on whether or not you have supplied an integer as the parameter, or a double as the parameter, or a string as the parameter. And it chooses which of the available methods to invoke based on what sort of parameter type you pass to it. Another example of this that's a little less obvious and a little bit more abstract is the division operator. So if we divide two integers, we get a integer result. But if we divide two doubles, we get a double result. If we divide an integer and a double, we get a double result. But in the underlying implementation in Java, this operator invokes some method. And so this single operator then is actually choosing which version of this method to use based on the type of operand given to it. So this is this idea of overloading. You can have the same name as long as the parameters are not the same in each of the method headings. So to make this concrete, let's look at a few examples. So in our first statement, we are declaring a method which is not going to return anything because it is type void, right? And print average, or print AVG, is the name. Just a plug here for proper style. Remember, methods start with lowercase letters and then they continue in camel case if it's multi-word. So we have a method here for print average. We have num1 as an integer and num2 as an integer that are parameters. Inside, it is going to sum the two integers, then divide by 2.0. So this expression will evaluate to an integer value. However, the total expression will evaluate to a double value, which is stored in the double average. And then we are going to print the average was, and then we are going to add average to that string. So string plus double equals string. So we're going to print the average was and then whatever the average was. So this is a way to average num1 and num2 and print that to the screen. But what if we had three numbers? And these are all three integers. What if we had three numbers that we wanted to average together? Well, this method doesn't quite cut it because it only allows us to average two numbers. So we make another method, print average. And instead of having two parameters, now we have three. And inside it, we're going to do something very similar to that we did with the last one. We're going to sum the parameters, and then we're going to divide by 3.0 to result in a double, store the double, print the double to the screen. But notice, how does the compiler tell the difference between print average with 3 parameters and print average with 2 parameters? Yes. To those of you who are saying or thinking it has a different number of parameters, as I just said, that is correct. So when you call print average, if you intend to invoke this particular version of print average, you will supply 3 parameters. And so based on the number of parameters, it will be able to tell which of the two you intended to use. But then we think about this and we say, all right, yeah, great. So we've got a 2 integer averager method and a 3 integer averager method. But what if we wanted to average 2 doubles? So we make another print average method. And in this one, we do the exact same operations as in the very first method. However, in this particular version, we are going to accept num1 and num2 as type double. So now, when the compiler attempts to identify which method to use, if there are 3 parameters, it knows which one to use. But if there's 2 available options. So then it checks the type. Okay, if it's 2 doubles that are supplied as parameters, then it knows that this is the appropriate method to use. However, if it's 2 integers, it knows print average is the appropriate method to use with the 2 parameters being integers. As a final note on this slide, I hope it's apparent also from the previous discussion that we don't need this method. Why? Because these 2 methods alone will accomplish all 3 methods' functionality. So this method will implement 3 integer averaging. This method implements 2 double averaging. And then if we were to delete this method, as I've shown here by drawing a red X over, if we deleted that method from our code and recompiled, then the compiler is going to go through and say, oh, okay, here's the ones that you use 3 parameters, so that means you want to use this version of print average, and here's ones with 2 parameters, and then it says, okay, oh, and some of them are using type double, so you're definitely using this version of print average. But then there'll be versions where you're using integers as parameters, and it says, you know, there's not a version of print average that uses integers as parameters and only has 2 parameters. And it says, okay, well, what if I promote the integer to other types? And then it goes through and it checks those types, and it goes, oh yeah, So I can promote the integer to a type double, and now it can use this version of print average and work correctly. So the only two versions that we needed to accomplish the same functionality was the bottom two. We could have removed the first method. This is overloading methods or overloading operators, using the same name for the method, but allowing the compiler to differentiate between the versions of the methods using the number of parameters or the types of the parameters. So we've written programs that print output to the console, and we've also written programs that read input from the console, and we've done both in some programs. So far, reading input is going to be the more complicated process. It's very easy to print to the console. It's a little more complicated to read from it and capture the user's input via a scanner. A program that reads input from the user and then uses that input in the program to affect the processing and then present some processed version of the user input is considered interactive. And interactive programs are more challenging for a number of reasons, but specifically, computers and users think in very different ways. Users tend to not do what we expect them to do, while computers always do what we should expect them to do. They always follow the rules given by the program, which is defined. Users do not. And therefore, you can't count on a user typing in what you expected them to type. For instance, if you told, if you gave the prompt, enter the number of years that you've worked for this company, many people would type in a number. Some people would type in a word, which represents a number. Other people, just to mess with the program, would type in squirrel. Since we can't count on the user, when we get input from the console, we have to validate it to make sure that it won't adversely affect the program. If we were expecting an integer and we attempt to assign what the user typed into an integer value, but what they typed was, squirrel, that's not going to go so good. We're probably going to get a runtime error. And so for this reason, what we're dealing with is a garbage in, garbage out situation. If the user gives garbage to the program, then this user is going to get garbage out of the program. So it used to be a lot harder even than just having to perform input validation to get good console input in Java. But thankfully, since Java 5.0, there are several methods which have been added for handling keyboard input. These methods are packaged and are found in the java.util package. And a package is understood to be a library of classes, and these classes contain methods which are used to make our job as programmers easier, because they are distributed code that performs some helpful common function. So we've seen this before, but just to touch on it again, in order to use a scanner, you have to import java.util.star, which gives you access to the classes which are stored in the java.util package. Another way to go about this, rather than doing .star, which would mean you are importing all of the classes built into .util, is to import directly java.util.scanner. So you're going specifically to the scanner class and importing it, rather than all of the classes in the utilities. So either one of these will work in the situation of using a scanner. So then you have to create a scanner object and assign it to a scanner variable. Now, we've talked about this, but once more, this allocates memory in the heap and creates a scanner object. While on the left-hand side, we have a declaration of a scanner type variable called keyboard. The assignment operator takes the memory location in the heap of our scanner object and assigns it into our scanner variable. So inside this scanner variable is not the whole object, but is the memory location of the object. Another way to go about this would be to declare the variable first, so scanner type, and then the name used would be keyboard. So we've declared a variable called keyboard of type scanner, and then assign, so this would be assignment, assign a new scanner object to that variable. So then to use a scanner object to retrieve input from a user, you have to invoke specific methods. So for instance, if we wanted to get an integer from the console that the user is going to type, we would say keyboard.nextInt, and this is going to get whatever the user types in. It's going to package it as an integer and return that value, and then we are going to assign that value to some integer variable we've created called n1. So we get whatever the user types as an integer and put it into our variable n1. You can do the same thing using the method .nextDouble, and that stores it into double D1. So we use the dot operator to access methods which are parts of objects, because the variable keyboard is just the memory location. So the dot operator is actually, it's called the dereferencing operator. So we have this memory location which is stored in our variable keyboard. We then dereference it. Dereference means to go to that memory location. So we go to the memory location which is stored in keyboard, and we use the method which is part of that object, which is called nextInt. So that's what's going on. We have to import the class or classes, depending on how you go about it, create the scanner object, assign it to a variable of type scanner, and then invoke methods to get the user input. So here are descriptions for common methods which are part of the scanner object: nextInt, nextDouble, nextLine. So nextInt reads a token. We'll talk more about tokens in a minute, but reads a token of user input as an integer. nextDouble is going to read a token of user input as a double. Next reads a token of user input as a string, while the last, nextLine, reads a line of user input as a string. All of these methods wait until the user presses the enter key before reading any data. So the user can type as much as they want. They can type this entire statement. The above methods all wait until the user presses the enter key before reading any data. Then the user presses enter, and these methods attempt to take that token and compress it into either an integer, double, string, whatever the case may be. So an example of this, system.out.print. So this is not going to print a new line. This is going to leave the carriage return at the end of the printout. How old are you? Then the user is going to type something in, potentially, but before the user has ever typed something in, you got to think, this program is executing very, very fast. So this is printed to the console, how old are you? And just as fast as that was printed out, Java creates a variable called age. It's an integer type, and it invokes the method keyboard.nextInt. So this method is already invoked, and it's waiting for the user to type something and press enter. When the user presses enter, this method returns the value that the user typed as an integer, and Java assigns that value to the variable age, and then the program will print out you typed and then whatever they typed along with a carriage return. So let's look at the execution of one more of these methods that is going to wait for a user to input something. So we have imported the scanner class. Notice we didn't do java.util.star, we did .scanner, so we imported specifically the scanner class instead of importing all classes which are part of the utilities package. Then we have created a class called userInputExample, and we have our main method heading. As the first statement inside of our main, we declare a scanner called keyboard. And as a note here, you should always include a prompt. It'd be very bad to invoke a keyboard.nextInt and have the computer waiting on the user to enter some value without telling the user that you're waiting on some value. That would be bad. They would not know what you were waiting on, and it would be a frustrating program to have to interact with. So we prompt the user using a print statement, how old are you? That prints out, how old are you? The next line of code executes almost instantly after the previous line. Let's talk through this in the proper order of operations. Remember, when we're dealing with an assignment operator, the expression to the right is always evaluated before the expression to the left. So, the expression to the right is an expression which contains a method call. So, to evaluate this expression, the program pointer is going to jump into that method and begin executing. So, the program pointer jumps into the nextInt method, and somewhere in there is a wait for enter key to be pressed. So this is going to sit here waiting for the user to type something and then press enter. So the program hangs right here, and we're just waiting until this user takes their time and types in some value and presses enter. We could wait for years if the user decided to not type anything. So finally the user types in 29, that's their age, and they press enter. So when they press enter, this method captures what they have typed, and it packages it as an integer, and it returns that value. So now this expression has taken on the value that the user has typed, so the value 29. Now the left-hand side is evaluated. So we have a variable declaration, and so we create the variable age of type integer. Finally, we execute the assignment. So we take the value 29 and store it into the variable age. Okay? Immediately after that, we have another assignment operator. So we again evaluate the right-hand side. 65 minus 29, that's going to be 36. The left-hand side is a variable declaration. So we declare the variable years, and we assign the variable years 36. And then finally, we are going to print out years until, or the value years followed by years until retirement. So we print out 36 years until retirement. So let's look at another example program where we're going to read multiple values, not just a single value in our method. So we're going to skip over some of the familiar things here. So we're going to import the java.utilities classes, so we can use the scanner, create the scanner object keyboard, and we're going to prompt the user for 3 integers. Finally, the part that we're really going to focus on here, we have 3 assignment operators along with 3 variables being declared. In the left hand side, we always evaluate the right hand side first, so we're looking at the keyboard.nextInt call. So at keyboard.nextInt, we are going to be waiting, as we've described previously, for the user to press enter. So we're not going to continue on with execution until the user presses enter. So our user, because they're in a hurry, they come down here and they type in 8, 6, and 13. And then they press enter once. So they didn't type in 8, press enter, 6, press enter, and 13 and press enter. They typed in 8 space, 6 space, 13, enter. So at this point they've pressed enter, which means this method is going to grab the next thing on the input stream, package it as an integer, and store it in num1. So it grabs 8, packages it as an integer, and stores it into num1. But it leaves 6 and 13 on the input stream. So since there is more valid input on the stream, the next call to this method will grab the next portion of the input stream between white space, package it, and put it into num2. And finally, the last call will grab the last available integer on the input stream, 13, and put it into num3. Then we can do our processing add them up, divide by 3, and cast that to a double. So actually, I said that poorly, because what really happens is that these three numbers are going to be summed together. Then the next highest priority operator is going to be the cast, because we went to the parentheses first, but then we go to the cast. So this summation, which would be what, 27, is cast into a double. So double divided by 3 is going to result in a double, and we get the double 9.0 stored into the variable average. Then we will print out the average is and whatever the average. So hopefully what you're getting from this example is that next int, when it's called, is going to attempt to grab the next available item on the input stream that can be characterized as an integer. It doesn't know what to do with white space, so it's going to leave that alone. It's going to throw away the white space that is in front of this 6. So the first integer is going to be grabbed by 8 following the user pressing the enter key, because there's no available input on the input stream until the user presses the input key, or the enter key. So the user types 8, 6, and 13, presses enter. So 8 space 6 space 1 3 is now on the input stream. This method looks at the input stream and is going to get the next thing on the input stream, which can be evaluated as an integer. It's going to package this 8. It's not going to touch the white space, and it's going to store that into a num. Then we call next int again. Well, hey, there's already stuff on the input stream, so we don't have to wait for anyone to press enter. They must have already previously pressed enter. But it's going to see white space, and next int knows, you know what, I don't care about white space. White space is not part of an integer, so it throws that white space away. And it sees a 6, and it's just a 6 by itself. It's not, 6, 7, 3, 4. It's not a multi-digit number. It's followed by white space, so it knows that this is all there is to this number. Grabs the 6, stores it into num2. Next int is going to perform the very same operation. I don't care about white space, you're not an integer. Grab the 13, store it into num3. So in this way, multiple integers which are typed in with delimiting characters in between, delimiting characters being white space, new line, carriage return, followed by an enter, can be evaluated separately using calls to next int. So a user can type in 8 space 6 space 13, press enter, and then your program can read in all three values using separate calls to next int. And this will work just fine. Something else we've talked about before, but it's worth mentioning again, do not declare multiple scanner objects in a single class, because this will cause Zybook specifically, the environment, it will cause it to crash, but in general it's considered bad style, because now you have multiple objects which point at the input stream. So what I mean by that is you have to pass the input stream, system.in, to the scanner constructor in order to build a scanner object that looks at the important, keyboard console input stream. So you don't want to have two things looking at the input stream, because some compilers can't handle it, specifically Zybooks. So don't do it, because we're using Zybooks to grade everything. You'll get a bad grade. Declare your scanner in the main function, and if it is necessary to use the scanner in any of the methods other than the main, simply pass the scanner into those methods. So as an example, we have some method called readSum3 declared here, which is going to return an integer value, and we're going to need to get 3 integers from the user via the scanner, and we're going to return the sum of those as an integer value. So to get the scanner into this method, we will declare a parameter in the parameter list of type scanner, and we'll call it console. So then in our main, when we call readSum3, we will pass it the console object that we created. So remember how this works. This will copy the value of console into the parameter which is called console. So the value which is in console is the memory location of our scanner object that we created. So we pass the location to this parameter console, and now the same object we created up here is being used in our program, or in our method. So we haven't made a new object, we've not copied our object, we've copied the location into this method, and we are using the very same object to do or to gather input from the user inside this method. So now let's talk about tokens. So our description for the various methods that we've talked about, like nextInt, was reads a token from the user and returns the value as an integer. So these are all described as reading tokens. A token should be understood as a unit of user input. So a token is going to be separated from another token by white space, and you should understand white space to be a literal space or a tab or even a new line. All of these would be considered white space. Based on this definition of tokens, how many tokens would the scanner read if it read the following input stream? How many tokens are in the following input, this line of input? The answer is 5. The reason is we have white space between 23 and John, white space between John and Smith, between Smith and 42.0, and between 42.0 and hello. So then we have a total of 1, 2, 3, 4, 5 tokens. Now, the beginning white space is not part of the token. The white space is stripped off. So the token would be 23, the next token would be John, the next token would be Smith, the next 42.0, and then the last double quote hello. So we've already introduced the idea of garbage in, garbage out. You know, a user does something unexpected and the program is not built to handle it, then we're going to cause major problems. So if we tell our scanner to interpret the next item on the input stream as an integer, however the next item is actually not an integer, then we're going to crash the program. That's a runtime error. So as an example, you print out in your main, what is your age? And you know, our class clown types in Timmy. Well, when he presses enter, the input stream is going to be looked at by our scanner object, and it's going to attempt to interpret Timmy as an integer, and it's not going to be able to, and therefore it's going to throw an error and crash. We'll talk more about this at a later time, and we'll discuss how to validate the input to make sure that, you know, class clown Timmy doesn't crash the program by joking around and typing in erroneous input. Here's an example program where we use the next method to read a word, or more properly, read a token from the input stream. Declare our scanner. We're going to prompt the user, what is your name? Next is going to return a value of type string. So we need to create a string variable in which to store this value. So our assignment operator evaluates the expression to the right first. We call console.next. The user types in some input, in this case, I'm a millionaire, all one word, presses enter. So there's now something on the input stream after the user presses enter. This next method is going to package whatever the user typed in as a string and assign that string value to name. Now notice this is similar to what we said with next int. If they were to type in multiple names separated by white space, those would be multiple tokens. So this is only going to read the next available token. So if they typed in 2 tokens separated by white space, this is only going to read the first token. So it's going to return that token as a type string and assign it to name. Then we are going to again assign something to the variable name, but we have to evaluate the right hand side expression first, because you always evaluate the right hand side in assignment before the left. So name.toUppercase, we are calling the toUppercase method, which is a part of the name object, which is a string object. So we know what this does, right? It's going to take whatever string data is stored in the name object, and it's going to convert that to all uppercase and return it as a new string object. So this will return a brand new string object, because strings don't change, right? So we can't actually change name. So rather what we do is we build a brand new string object and return the memory location that points to that new string object and store that now in our variable name. So what happened was we called console.next, which grabbed the next token on the input stream and made a string object in which it stored that token. Then we put a reference to that object inside the variable name. When we come down here and called name.toUppercase, we built another new string object, and we said, we're tired of that old one that we got from the console, we don't care about it anymore. Take this new string object's memory location and store it in name. So we created an object, stored its location in name, created a new string object, and now we are storing its location in name. And the first one is gone. We don't care about it anymore. So now we're going to print out the statement name, which is going to print out the actual data in the string name, has name.length. So this will give the integer length of the string variable. So name has the length of the string letters and starts with, and then we're going to use the substring method of the string object class to get the string which begins at index 0 and stops immediately before index 1. So remember, we include the starting location, but we don't include the ending location. So this is only going to return the first character. So then this prints out, what is your name? The user types in, I'm a millionaire. We print out, I'm a millionaire, all in uppercase, because we got rid of the original string, built a new string which was all in uppercase and assigned it to name. I'm a millionaire uppercase has 14 letters and starts with I. So the next method when dealing with strings is going to get the next token on the input stream and return it as a string. But keep in mind, if the user were to type in for their address, say, let's say they typed in Oak Lane with a space in between Oak and Lane. Well, next is going to get the token Oak and return that as a string. But it's not going to return Lane, because that's a separate token. If we wanted Oak Lane, and we didn't care about the white space in between, we wanted to just grab the entire line of input until it reached a carriage return, which is when the user presses enter, we could use the next line, which is going to get everything on the input stream up to where the user pressed enter. Now this is a way we could, capture an entire sentence, including white space. Next would be a way to capture just individual words or numbers separated by white space. So understand that. Next will return the next token. Next line will return the next line all the way until a carriage return. Next int and next double are very similar to the next method, because they're going to also get the next token. The only difference here is they're not going to return it as a string type. They're going to attempt to interpret it as an integer or a double type, which could cause problems if the value which the user typed in isn't a valid integer or double. As a final note, keep in mind case sensitivity is going to be important here, because let's say that you wanted to say, well, what is your home state? And if their home state was Tennessee, you could say, you live in the same state as Vanderbilt. Well, in that case, you would probably be doing a string compare. So you would be doing, you would store the user's input into some string variable, and you might say, user input dot equals, and then give the value tn as a string to see if they typed in tn. Great plan, but what capitalization did the user use? So we would need to know, did they type in, lowercase tn, mixed case tn, or all uppercase tn? Another way to do this would be to simply do what we did in the previous slide, which was convert it to all uppercase or all lowercase. That way we don't have to worry about what they typed in. We can make it into we can make it what we want it to be, and we can convert it to either all upper or all lower, and then process it. So consider this next situation. We declare a variable called n of type integer and two variables of type string called s1 and s2. What we're attempting to do here is read an integer and then read two lines of input from the input stream. So we say keyboard.nextInt, and then we're waiting for the user to type something in, and the user types in 5440. Then they press enter. Then the user types in or space bust, and they press enter. The way that the program will interpret this and read this is the next int is going to grab 5440, ignoring the preceding white space, and store it in n. However, S1 will be empty. The reason is the input stream is now down here, but there's still a carriage return sitting here that hasn't been used yet. So next int read the 5440 and ignored the white space before and got rid of it from the input stream, but then it stopped at the next white space, which would be this carriage return, and it did not read this in and get rid of it. So this carriage return is still sitting on the input stream unused and ready to be read by the program. So when we call next line, it will begin to read the input stream until it finds a carriage return. Well, the very first thing it finds is a carriage return. So it's going to return everything it read up to that point in a string value. It read nothing, right? It found no characters before the carriage return. So in that case, S1 is going to contain an empty string. Then in the following next line method call, we will read or bust and stop at the carriage return. So this has, at this point, removed everything from the input stream. So just to make sure this is clear, there is a carriage return that happened right here to make the pointer, the cursor, go down to the next line. And there's also a carriage return here that occurs because the user pressed enter to say, I'm done typing things in. So when the program begins to evaluate, next int is going to read until it sees white space. And that can be a space, it can be carriage return, doesn't matter. It's going to read until it sees that white space. So 5440 is read by next int. But then it doesn't get rid of the white space it stops at. It gets rid of the preceding white space. So if there was anything up here, it's been wiped out. But anything after it, it leaves in place. So when our call to next line occurs, next line reads everything until it sees a carriage return. So the first thing it sees is a carriage return. And so therefore it returns nothing. It's just an empty string. Then when we call the next line method, we will read or bust up to the carriage return and store that in next line. So if you're reading a string value after using some method like next int or next double that reads the token up till white space, you must remember to skip whatever lingering carriage return exists if you intend to read another line in. So for instance, in the situation from the previous slide, the user was supposed to type in something and then another line of text. So 5440 followed by the line or bust. In this case, we need to be aware that after reading in an integer, again, or a double, or anything that reads a single token, after reading in a single token, we are going to leave behind white space or carriage return. So what we can do is actually make use of this. If we wanted to read in the integer and then read in the words in the next line, the way we could go about that is by reading in the next int, realizing that there's going to be a carriage return left behind, so using the next line method to grab the carriage return, and we throw this into something we're calling discard, and then read in the next line of input that we wanted to actually use in the program. So now n would be set to 5440, discard would be populated by an empty string, and S1 would contain or bust. And this is what we intended in the program from the previous slide. At this point, we're going to work through a live example in IntelliJ. So we will prompt for a user's full names, first, middle, and last, then reformat and print it. As an example, if someone typed in John Quincy Jones, the program should reformat that to John Q, period. Follow along with this example. Work through it on your own machine as well. This will help you to get used to IntelliJ and just ensure that you are understanding everything that has been presented in this lecture.